Hello guys, welcome to the Java 0 to Infinity course in which we are going to master the Java the right way. So this is going to be the first video of this series, and in this video we are going to learn about the introduction to the programming and the Java. So what is our today's agenda? So in today's video we are going to learn about what is programming, what is programming language, types of programming languages, what is the high level language and the low level language and difference between them. Then we will see how does the high level language is converted into machine code, that is how code execute, and we will learn about the compiler and the interpreter. Then we will move to the Java, introduction to the Java, and then we will see how the Java source code is converted into the machine code, like how Java code execute or how Java works, like JVM and bytecode. So without any further ado, let's start the today's video. So first we will see. So programming is nothing. Programming is the process of giving instructions to a computer to solve a real world problem. These instructions tells the computer what to do. So what is programming? Programming is the process of giving instruction to a computer to solve a real world problem. And these instructions tell the computer what to do. So, and this set of instruction that we give to a computer, is known as program. So, what is programming? So, programming is the process of giving a set of instruction to a computer. This process of giving a set of instruction to a computer is known as programming, and this set of instruction that we give to a computer is known as program. So, let's say example. So, consider we want to give the instruction to a computer to add two numbers. So first we will write the instruction like first take two numbers, like take the two numbers as input, second add them, and third show a result. So we will write this instruction in a file and we will give this instruction to a computer to perform. So this process of giving instruction to a computer is known as programming, and this set of instruction and the set of instruction that we give to a computer is known as program. So this is program, and the process of giving this program to a computer is known as programming. And let's say the second example, let's say we want to check whether a given number is even or odd. So what we will do? So first we will take a number as an input. So we will give the instruction to a computer like that. So first we will take a number, we will say divide by 2. If the remainder is 0, then the number is even. If the remainder is not 0, then it is odd. So we will then show the result. So we will write this instruction in a file and give this instruction to a computer. So this process of giving the set of instruction to a computer is called a program, and this file, a set of instruction, is called a program. So in simple word, we can say that the programming is nothing but it is giving the step-by-step instruction to a computer to solve a real world problem, and the set of instructions is called a program. So now we have learned that what is programming. Now let's say what is a programming language. So a programming language is a language used to give instruction to a computer. Like we give instruction to a computer, and this process is known as programming. So in what language we give the instruction to a computer? So the language that is used to give instruction to a computer is called program. For example, we humans give instruction to each other with the help of Hindi or English language or any other language. So this is known as human language. But the computer cannot understand the human language. The computer uses another set of languages to give the instruction to them. So these languages that are used to give instruction to a computer is known as programming languages. And what are some of the examples of the programming language? So for example, machine language is an example of programming language. Then we have assembly language, which is also a programming language. Then we have Python, C, and Java. These are all example of the programming languages. So what is it? So these are the languages that are used to give the instruction to a computer. So this is known as programming language. Now, but there are different types of programming languages, but there is one key point to note. But computer can only understand zeros and one. That is, computer can only understand the machine language. That is, this is computer and this is our set of instruction written in some language, but our computer can only understand the machine language. So all the other languages, like all these other languages that are not the machine languages, need to translate. We need to translate it into the machine language, and then give this to a computer, because computer can only understand the zeros and ones. So this is one key point to keep in mind. Like, there are different types of programming languages that we use to give instruction to a computer, but computer can only understand the machine language. So therefore, all the other languages must be translated into the machine language in order to give the instruction to a computer. So depending upon this, the programming languages can be classified into two types. First one is the low level language and second one is the high level language. So let's see each in one detail. So first, see what is the low level language. So low level language is a language that is closest to the computer hardware. It is difficult for human to understand but easy for computer to understand. So what is the low level language? Low level language is a language that is close to the computers and it is very easy for a computer to understand, but it is very difficult for humans to understand. So this is our computer and this is human. So this language is very close to the computer hardware, but it is very far from the human language. So it is very difficult for the human to understand it, but the low level language is very easy for the computer to understand, and it ensures a very fast executions. So what are the examples of the low level languages? So there are two types of the low level language. First one is the machine language, that is zeros and one, and second one is the assembly language. So let's see what is machine language. So machine language, in machine language, the instruction that we give to a computer is written in the binaries, that is zeros and ones. And so this is a computer and the instruction that we give to a computer, it is written in the form of zeros and ones. So this is directly understood by the computer and there is no need for translation. So the machine language is directly understood by the computer and therefore there is no need for translation and it is very fast execution. For example, this is one instruction that is written in the machine language. So what is its disadvantages? Since the machine language is written in the binaries, so it is very difficult for human to write and debug the code. So it is the example of the machine language. In machine language, the instructions are written in zeros and one. So, and these instructions are directly understood by the computer, but it is very hard for human to understand or write or debug it. But the machine language does not require any translation because it is directly understood by the computer. For example, this. And what is disadvantages? Disadvantages is that it is very hard to write and debug. Now let's see what is assembly language. So assembly language, in assembly language, it uses the short mnemonics instead of the binary, and it is easier for human than the machine languages. So what is the assembly language? Assembly language uses the short mnemonic instead of binaries. In machine language, we write the instruction in the form of binaries, but in assembly language, we use a short English mnemonic. For example, we use add in order to add the two numbers, but in binary language, in machine language, we need to write it in the form of zeros and ones. So therefore, it is easier than the machine language. Example, if we want to add the two numbers, simply we will write add A and B. If we want to move B to A, then we will write move A, B. So but in machine language, we need to write this instruction in the form of binaries and it is very difficult for human to understand. So, but as we have already know that this is our computer, and this is our assembly language. This is our assembly language. But we know that the computer can only understand the machine language. So there is a need for translator. So there is need for translator. What does this translator do? This translator will translate this assembly language code into the machine code, zeros and ones, because computer can only understand zeros and ones. So this assembly language must be translated into the machine language in order for the computer to understand it. So there is a need of translator in the assembly language, and this translator that translates the assembly language into machine language is known as assembler. This is known as assembler. So now let's see what is the high level language. So as from the name signifies that it is a high level language, that is, it is easier for human to read and write. It uses the English like syntax. So what is the high level language? High level language is easier for human to read and write, and it uses the English like syntax. So examples like Python, C, Java, all are the example of the high level language. In this the instruction. So there is need for translation because high level language are easy to read and write for the humans. It is easy for and to write and read for the humans because they use the English like syntax. But computer do not understand these languages. So because computer can only understand the machine languages, zeros and ones. So our code must be converted into the machine code in order to execute it. So what it means by, as we have already told, this is our set of instruction written in the high level language, and this is our computer. This is our computer, and it can only understand the instruction that are written in the zeros and ones, that is machine language. So the computer can only understand the machine languages, but the code that we have written in the high level language uses the English like syntax. So there is need for some kind of translation that translate this high level language into the machine language, that is zeros and ones, so that the computer can understand it. So this translation is done using either compiler. So this translation is either done with the help of either compiler or interpreter. So let's see what is the difference between the compiler and the interpreter. So both the compiler and interpreter convert the high level languages into the machine languages so that computer can easily understand it. But the way it converts the high level language into the machine level language differentiate. So let's see the difference between the compiler and the interpreter. So what does both the compiler and interpreter convert the high level language into the machine code, but there is difference between how they do it. So consider we have our code written in the high level language, like let's say we have 3 instructions in our high level. We have 3 instructions. Consider we have 3 instructions in our high level language written. So this is our source code. So what is the difference between the compiler and the interpreter? So compiler translate the whole program into the machine language at once. On the other hand, the interpreter convert the instruction line by line. So let's see. So here is our source code. So what does compiler do? So first, what does compiler do? Compiler take the whole program, convert it into the machine language. So it is the instruction number 1, it is zeros and ones. The second instruction is also converted into zeros and ones, let's say this, and the third instruction is also converted into the zeros and ones. And then this instruction can be easily executed by the computer. On the other hand, in case of the interpreter, what happened? So what does interpreter do? So suppose here is our interpreter. interpreter. So what does it do? It take the first, it translate the high level language into the machine level language line by line. So it first take the line number 1, convert it into the machine language, convert it into the 0011, convert it into the machine language, and then execute it. Again it will it will take the line number 2, convert it into the machine language, and then execute it. So in case of the interpreter, the translation of the code is done line by line, but in case of the compiler, the whole program is converted into the machine language at once. So due to difference in the nature, how does the translation occur? The compiler, the execution speed of the compiler is fast, because now after the code is converted into the machine code, now the computer can directly take this file and execute it, and it is contain the machine code. But in case of the interpreter, it is slower. Now in case of the compiler, the error detection. So let's see about the error detection. So suppose we have our error in the line number 3. So in case of the compiler, the compilation will done and see that there is error in the line number 3, and the compilation will failed. So the error will be detected after the compilation. But in the case of the interpreter, it is immediate, line by line. For example, the first line will be executed, there is no error. Then the second line will be executed, no error. So now when the third line comes, when the third line comes for the translation, the interpreter will see that there is error in the line number 3, and it will throw the error. So in case of the interpreter, the error detection is immediate, line by line. Now in case of compiler, it generates the separate executable file or object file. So this is known as executable or object file. So in case of the compiler, the separate executable or exe file is generated. But in case of the interpreter, no separate file is created. As you can see here, there is no separate file is created. Now reusability. Now once the compilation is done, in case of the interpreter, once the compilation is done, now separate file is created, that is exe or object file. Now this file can be executed again and again without need for the recompilation. So the executable can run again and again without need for the compilation. But in case of the interpreter, there is no separate file is generated. So every time a program need to be executed, it need to be reinterpreted again and again. So what are the example of the languages that uses the compiler? So C and C++ are the languages that use the compiler based approach, a compiler for the translation, while the other hand, the Python and the JavaScript uses the interpreter for the conversion of the high level language to the low level language. So this is the difference between the compiler and the interpreter. I hope you understand it. Now let's move to the Java. Like, what is Java, and whether it is, and see whether it is interpreter based or compiler based. So first, say what is Java. So Java is a high level programming language. That is, it is easier for the human to read and write, and uses the English like syntax. And the Java is fully object oriented, because, and what is meant by the object oriented? It means that all the thing that we will do in Java in the form of classes and the object. So the Java is fully object oriented programming language, and the Java is platform independent. So we will see why the Java is platform independent soon. And it is created by the James Gosling. So Java, James Gosling is known as the father of the Java, because it is created by the James Gosling at Sun Microsystem. So it is Java. So what is Java? Java is a high-level programming language. It is object-oriented. It is platform-independent. It is created by the James Gosling, and he is also known as the father of Java. Now let's see how the Java code executes. So first we write our code in Java and save it into the .java file, and this file is human readable. Now this file is taken by the compiler known as javac and compiled it into the .class file that is also known as bytecode. Now this bytecode is intermediate form. It is not a machine layer. It is not the machine code. It is the intermediate form. It is intermediate form. It is not a machine code. So now, but we know that the computer can only understand the machine code. So this intermediate form must be converted into the machine code, that is zeros and ones. So here comes the JVM. The JVM come and take this .class file. Take this .class file and interpret it into the machine code line by line, and now this machine code can be easily executed by the computer. So this is the whole process how a Java code execute. So this is the step number 1. It is known as compilation step, and this is the step number 2, which is known as interpretation. So that's why Java is both compiler and interpreter based language. So first the Java code is compiled into the .class file. It is also known as bytecode, and then this bytecode is interpreted into the machine code line by line by the help of the JVM. So this .class file, it is not a native machine code. It is an intermediate form, and JVM interpret this to the native machine code. So this .class file is intermediate form. It is not a native machine code. The JVM take this .class file and interpret this into the machine code. Now this file, the .class file, it remains same and can run on any device. For example, we can write our .java file on Windows and compile it into the .class file in Windows. Now we can take this .class file and can run it on Mac OS or Linux on any systems, because this Java is platform independent. Why Java is platform independent? Because JVM, now this .class file is taken by the JVM and interpret this into the native machine code. So this JVM is different for the different OS, because native machine code is different for the different operating systems. So this is taken care of by the JVM. For example, in case of the Windows, this JVM is different. In case of Mac OS, this JVM is different. So in Windows, the .class file is taken by the JVM and converted into the native machine code to the Windows OS. But in case of the Mac OS, this .class file remains same, but only the JVM will change and it will convert this into the native machine code of the Mac OS. So that's why we say that the JVM is platform dependent, but bytecode is platform independent. Now I hope you understand it. Now let's see in detail. Step number 1, that is compilation step. So what happened in the step number 1? Step number 1, the Java file is converted into the .class file. It is known as the compilation phase. Now let's see what happened in the compilation. So the compiler, which compiler? The javac check for the syntax error, types error, etc. And then what does it do? It provides the optimized bytecode. And now it is known as bytecode, and this bytecode is optimized, and it is not a native machine code, but computer can only understand the machine code. So this .class file is converted into the machine code in the step number 2. So now this .class file is the intermediate form, and it is bytecode. It provides the optimized bytecode. It is not a native machine code. Now this make our code portable, and same .class file can run anywhere a JVM exists. Now this .class file can run on anywhere. For example, where the JVM exists. So this, suppose this is our Windows OS. Now this .class file can be taken by the JVM and it is interpreted into machine CAD and can executed easily. Now again this .class file can taken by the JVM and can convert it into the machine code and can be executed in Mac OS also, or Linux also, or anywhere where a JVM exists. So this .class file remain platform independent, but this JVM is a platform dependent because it is different for the different OS. For Windows OS, this JVM will be different. For the Mac OS, this JVM will be different, but this .class file remains same. So therefore it is saying that this makes our code portable and same .class file can run anywhere a JVM exists. So this is the step number one. Step number one, the compilation will be done, in which the .java file is converted into the .class file, and this .class file is the platform independent because it can run anywhere a JVM exists. But the JVM is a platform dependent. It is different for the different OS. Now, what happened in the step number two? So the step number two is the interpretation. Because why there is need of interpretation? Because the computer can only understand the zeros and ones, that is machine code. But our .class file is the intermediate form optimized bytecode. It is not yet converted into the machine code. So there is need for the conversion of the .class file into the machine code. So it is done with the help of the interpretation. And who done it? JVM does it. So what does happen? So JVM interpret a just-in-time compiler compile the bytecode into the native machine code at the runtime. So the JVM, now here is our .class file. It is our bytecode. So what happened here? The JVM take this file and interpret this to the machine code line by line and execute it. Or there is a just-in-time compiler which translate the hot code paths into the native machine code and reuse it again and again. We will see it soon. We will see in the next slide what is the just-in-time compiler. So just-in-time compiler improve the performance by translating the bytecode to machine code one and caching it. So now let's see. So first say what is the JIT? JIT stands for just-in-time compiler. JIT compiler. So let's say what is the just-in-time compiler. So basically here was our .java file. It is converted by the JavaC compiler into the .class file. .class file, it contains the bytecode. It contains the bytecode and it is optimized bytecode. But our computer cannot understand the bytecode, so it needs to be converted into the machine code, zeros and ones. So who did this? Either JVM interpret this or just-in-time compiler compile it into the machine code and reuse it again and again. So what is just-in-time? So just-in-time compiler convert the bytecode to the machine code while the program is running. It was added. Initially it was not there, but later it was added to speed up the execution. So let's see detail. So initially here is our .class file, and what happened? The JVM start interpreting the bytecode as usual. So what happened? Now the JVM observed that there is some method and the loop which are executed frequently, and JVM call this code the hot code part. Now since there are some method and the loops that are used again and again, so the JVM has to interpret this again and again to the machine code. So instead of interpreting it again and again, the just-in-time compiler was added. What is its role? So the just-in-time compiler compile the hot code part into the machine code specific to your CPU. For example, consider here is our .class file. Here is our .class file. Here is our .class file. And consider it is our hot code. This code is used again and again in our code. This code is used again and again. So JVM has to interpret this again and again. So instead of interpreting it again and again, what does just-in-time compiler does? Just-in-time compiler take this hot code path, convert it into the machine code at once, compile it into the machine code, and cache it. So when later in the program, whenever this hot code part occur or hit, there is no need for the interpretation. Its machine code can be directly be used, so it speed up the execution. So what does the just-in-time compiler? Just-in-time compiler take the hot code path and convert into the machine code. So and the JVM reuse that machine code directly for future calls. So in the future call, if this hot code part comes, then it can directly reuses this machine code. So thus there is no need for the interpretation. So there is no more interpretation for that part. So thus we can say that just-in-time compiler improve the performance. So what is the role of the just-in-time compiler? The role of the just-in-time compiler to improve the performance by converting the hot code part to the machine code. So this is the just-in-time compiler. Now let's see one confusion that remain among the students, like why Java chooses the two-step approach, like first it compile it and then it interpret it with the help of JVM. Rather, why it can't just directly interpret the Java file into the machine code directly? Still, it remains the platform independent because the JVM will take this .java file and convert it into the machine code line by line, and this JVM remain the platform dependent, and this .java file remain platform independent, and the JVM convert the source code into the machine code line by line according to the given OS. Still, Java remain the platform independent. Same Java file can run anywhere where JVM exists. So why Java don't chooses this approach? Instead, it uses the two-step approach, that is first it compile it and then it interpret it. So let's see why. Let's see why it does it. Because if JVM directly interpret the .java source file, that would be very slow and error prone. Because if JVM directly interpret the .java file into the machine code, then that would be very slow and error prone, because source code is human readable and full of extra information. Because source code is human readable and full of extra information, but the interpreter does not want all this extra information like comments and etc, all of this, like, and every time when we run it, there is need for the syntax checking, parsing, etc. every time we run it. For example, we run it first time, again it needs to do the syntax checking, parsing and all other stuff all the time when we run .java file. So but when we converted this .java file into the bytecode, the syntax checking, parsing and all this happen only once, and all the extra information from the .java file is removed and produce the optimized bytecode. So this is optimized bytecode. Now every time when JVM need to run it, it does not need to care about the syntax checking, parsing, all of this, because already the compiler has done it, converted it into the .class file, removed the extra line of information, done the syntax checking, parsing and any error detection. So there is no need for the JVM to check all of this, and JVM can directly start interpreting the .class file or bytecode into the machine code directly. So therefore the JVM can execute the bytecode faster. That's why the Java chooses the two-step approach instead of one. I hope you understand it. Now there will be one more confusion among you, like why JVM chooses interpretation instead of compilation. For example, here is our .java file. First it converted into the .class file, and then it is interpreted into the machine code. So the first step is the interpret. So first step is the compilation, and the second step is the interpretation. So instead of interpretation, why Java chooses the interpretation only and not compilation? Why? So let's see. Because the Java was designed for program that can Java was historically designed for the program that can be sent over the network and executed safely and dynamically on any machines. This means that code might not exist at the compile time. For example, here is our .java file. First it compiled into the .class file and then it is interpreted into the machine code. It is the interpretation step and it is the compilation step. So Java was initially designed for the program that can be sent over the network and executed safely and dynamically on any machine. So if instead of interpretation, if compilation was chosen, so that because the program is sent over the network, it means that the program code might not exist at the compile time. So in case of the network-based programming, the classes can be downloaded or replaced dynamically, but it is not possible in the compilation. Because there is need with the compilation, because we can't safely or easily load new classes at runtime in case of if the compilation is done. Because every time we load a new class, we need to recompile it every time, because we would have to recompile it on every update or network download. That's why it does not choose compilation, instead it chooses the interpretation. For example, here is our .class file, and suppose we get the new file over the network and added another .class file. Now the JVM can safely execute this .class file safely. That's why the Java chooses the interpretation instead of compilation. That's why JVM chooses interpretation instead of compilation. I hope you understood that how Java code is executed on the user machine, and why there is a need of two-step approach, and why JVM chooses interpretation instead of compilation. So this takes us to the end of the video. In the next video, we will understand deeply the architecture of the JVM, like what their internal working of JVM, and see different component of the JVM. So that's all for the today's video. Thank you.